Welcome to VK's Coding. In this video, we'll talk about Singleton Design Pattern. So Singleton Design Pattern is one of the gangs of four design pattern and comes under the creational design pattern category. Singleton Design Pattern restrict the initialization of a class and ensure that only one instance of the class exists in the Java virtual machine. Singleton class must provide a global access point to get the instance of a class. And singleton pattern can be used for logging, driver objects, caching, and thread pools. It means like singleton design pattern is a creational design pattern, and whenever we require to create only one object of a class and to give as a global access point to all the places wherever it is required, then we must use a singleton design pattern for creating the objects. And there are five ways we can create a singleton class. So first one is the eager initialization, second one static initialization, third one is the lazy initialization, fourth one using the synchronized method thread safe singleton, and fifth one is the synchronized keyword using thread safe singleton. So let's see all this type of creation in IntelliJ via code wise and to get the more understanding on. So this is the first singleton design pattern. In that we are trying to create through eager initialization. And if you see, I have given the name as singleton eager initialization as a class name. I have given here as a static final one variable, so it cannot be accessed from outside. And in the beginning itself, I am initializing the new object to this class, and I am making the constructor as a private, and I have defined and I am giving one method here, static method. So, and this static method will return this variable. So whoever is calling up from the outside, it will get the same object every time. So let's see through the driver method and run this program once. So this is my main method and I am calling singleton eager initialization instance two times to get the two instance, and then I am comparing the hash code of both the instance. So let me run this program quickly. So if you see here, the hash code of both the objects is same. It means once the object is created, and no matter however time we wanted to get the object, we will get the same object for that particular class. So this we have achieved through eager initialization. So there must be some advantage and disadvantage of all these approaches and will be evolving. So for eager initialization, there is some advantage and disadvantages as well. So first one is very simple to implement, but it may lead to resource wastage because instance of a class created anyway, whether it is required or not required. Because we are not checking any condition, we are just creating the class here. So at the time of class loading, it will be created that particular object, whether it is required or not, but it will be get created. So that's why we can say that CPU time is also wasted in the creation of the instance, and if it is not required. So let's see what is the another approach through which we can create a singleton class. So second approach is a static block. So we can create the singleton class in a static block. We can create a here using the static block. We can initialize the a new object for a class. So what I have done here is I have defined one static variable here. The name is the static variable as an instance, and again I have made as a private to this constructor. So from outside nobody can initialize the object for this class, and in the static block I'm initializing this class. So when during the load time of this class, whenever the class is getting loaded into the JVM, that time this object will be created, and every time when somebody is trying to access through variable, so we will get it that person will get the same object. So let's see this example through the driver method. So here I have written the driver method and I'm trying to access that particular variable static block initialization, and I'm creating the two objects using accessing the instance variable of a static block, and then I'm printing the hash code. So let me run this program quickly. So if you see the hash code of both the objects are same, it means only one object is created and that is shared between the all the requirements here. So we try to access the create the same object one more time. So we are getting the previous object because that object is created. So this is how we can create the singleton using the static block, but there must be some disadvantage and advantage as well. So let's see quickly what is the disadvantage or advantage. So first advantage is very simple to first one is very simple to it is implement, and no need to implement the guest instance method here. Uh, so it can be directly accessed through this well, but it may lead to a resource wastage because the instance of a class is created always, whether it is required or not required. So we can see that the CPU is also wasted in the creation of the instance if it is not required. So let's see what is the another approach we can improve it. So the another approach we can go through the third approach is lazy initialization. So in the lazy initialization, what we are going to do is first we define the instance variable here as a static and the private. So cannot this private variable cannot be accessed from the outside. And then we are making the constructor as a private. So from outside nobody can create the new object for this class. And the third one, we have defined one more method here as a guest instance. So from the outside, the people need to call this method to get the object. And before creating any object, first we are checking if this instance is null or not. If it is null, it means it is not having any object. So we can create a one object and we can assign to this instance variable and we'll return this instance variable. So this is how we are doing the lazy initialization. So let's quickly check this program with the driver method. So in the driver method, I am calling the get instance method of this particular class. This gets instance I am calling here. And I'm trying to create the two object and then same thing I'm trying to compare the both of the hash code. So let's run this program and see the output. Yeah, so if you see here, both the hash codes are same of this program. It means only one object is created, and if the second time we wanted to create the object, same object is returned to us. So what is the benefit and the disadvantage in the lazy initialization when we create a singleton using this? So let's see quickly what is the problem with this approach. So here we can say that object is created anyway when it is needed, and so we are overcome with the wastage of resources and CPU time. But it multi-threading environment, it break the singleton property. So this is the disadvantage using this program as a singleton, making the class as a singleton. So it will not work in a multi-threaded environment. So again, we need to improve our code. So let's see the next approach, how we can improve from this approach. So the fourth approach is thread safe synchronized method. So what we are going to do here is synchronize keyword in a method. So in this program, you see I have defined as an instance variable here and made as private. So it cannot be accessed from the outside. And again, I have made the constructor as private. So from outside, nobody can create the object. And here I have used a synchronized method. So multiple thread cannot access this particular method. So only one thread can access the this particular method, and in the instance variable we are checking if it is not null, then we are creating a new object of this class and we are returning this one. So let's quickly check this program through the driver method. So here I have written the driver method. I am calling the get instance two times and then we are comparing the hash code again with the same way how we did it for all the programs. So if you check here, we are getting the same hash code for these two. It means same object is getting used for many times. So we have achieved singleton and it is thread safe as well because in this method only one thread can access at a time. So we have made our program compliance to the multi-threaded environment as well. So let's see, can we improve further on this? So yes, we can improve further on this. So let's first discuss about the program. So this is kind of a lazy initialization is possible in this approach, and it is thread safe definitely because we have used the synchronized keyword in a method. But the problem is in the get instant method is synchronized, so it multiple thread cannot access it. Suppose if this object is already initialized, so that time we can directly return the instance. But even the object is initialized, we cannot return. Only one thread can enter into this method. So that is a problem with this approach. So we need to improve our code. So let's see one more level up. So we can use a synchronized block. So let's see quickly that program here. A variable, and I made it as a private, and here I have defined a constructor as private, and here we have defined the public static singleton get instance. So it can be, this method can be used for a outsider to get the instance of a class. So first we are checking the instance is null or not. If instance is null, then we are coming into this block. If instance is not null, then we are returning the object from here itself. But if instance is null, then we are first locking this class, so only one thread can access. And again we are checking if the instance is null, then we are creating the instance and then we are returning. We can improve the performance what we are getting with the synchronize keyword in the method. So in that, if we apply in the method, so multiple thread cannot access this method. But if we apply the synchronize keyword in a block, so multiple thread can access this method. If the object is available, all the threads can get the objects, those particular objects. But if objects are not available, then only one object is allowed to create it. So this way we can improve the performance. And let's test this program through the driver code. So let's run this program. So here we are getting the same hash code for both the object. So this is the lazy initialization also possible here, and it is thread safe also, and the performance overhead also get reduced because of synchronized keyword. So we have seen all this type of example: eager initialization, static initialization, lazy initialization, synchronized method, thread safe in singleton, synchronized keyword, thread safe singleton. So all these 5 way we are trying to create the singleton classes, and we have tested that, and we get to know what is the advantage and disadvantage to all of that. So thank you for watching the video.